computer. Complex numbers. We're going to start with a imaginary unit first, and we're going to say this, that the imaginary unit I is the complex number whose square is -1. Yeah, they're kind of like fairy tales. Or it's like fairy dust. Or imaginary. Yeah, imaginary. So I squared is equal to -1. And I is equal to the square root of -1. So we're going to say for any positive number A, the square root of -A is equal to the square root of -1 times the square root of A, which is equal to I times A. So here's what we're going to be doing today. You're going to be simplifying a number using I. So let's simplify using I. You were told earlier in your lives that you can't have a negative under the radical. All right? And now you still can't have a negative under the radical, but you can pull that negative out from under the radical and replace it with the letter I, which is an imaginary unit. So if you have to simplify using I, and you have the square root of -7, say. The square root of -7, why does it keep doing that, is equal to the square root of -1 times the square root of 7. And since the square root of -1 is equal to I, then if we were to simplify this using I, then it simplifies to I radical 7. Do what? Up or down? Down. The square root of -10 is equal to the square root of -1 times the square root of 10, which is equal to I radical 10. you basically pull a negative sign out from under a radical and replace it with an I outside the radical. Now, if you've got the square root of negative 18, remember now you've got the square root of negative 1 times, oops, that's a negative 1 under there. You got the square root of negative 1, but the number 18 has a perfect square in it. So this is the square root of negative 1 times the square root of 9 times the square root of 2. All right, and this square root of 9 simplifies to a 3. The square root of negative 1 simplifies to I. And that leaves us with 3i times the square root of 2. Square root of negative 12 is equal to the square root of negative 1 times the square root of 4 times the square root of 3. Because 4 times 3 is equal to 12. So the square root of negative 1, that simplifies to I. The square root of 4 simplifies to a 2. So in simplest form, we've got 2i times the square root of 3. If you get a perfect square under the radical, if you get the square root of negative 25, that's the square root of negative 1 times the square root of 25. The square root of negative 1 is I, and the square root of 25 simplifies to 5. So in simplest form, the square root of negative 25 is 5i. Square root of negative 48 is equal to the square root of negative 1 again times the square root of 16 times the square root of 3. Your square root of negative 1 simplifies to I. Your square root of 16 simplifies to 4. So we get 4i times the square root of 3. That is your simplest form of the square root of negative 48. Any questions on simplifying radicals with a negative underneath the radical using an imaginary unit? All right, so here we're going to say that an imaginary number is any number of the form a plus bi. where A and B are real numbers. And B is not equal to 0. Imaginary numbers and real numbers. So we're going to say imaginary and real numbers together make up a set of complex numbers. You can write a complex number in the form A plus BI. In the complex number plane, the point AB represents the complex number A plus BI. To graph a complex number, locate the real part on the horizontal axis and the imaginary part on the vertical axis. Come on, baby. Too far. the absolute value of a complex number is its distance from the origin. In the complex plane. So the absolute value of A plus BI is equal to the square root of A squared plus B squared. So the second part of your assignment today, you're going to be asked, what are the graph and absolute value of each number? So what are the graph and absolute value of each number? And first we get -5 plus 3i. All right, so here's how this works. If you have to graph this and find the absolute value of it, the first thing we do is we draw a coordinate plane. The horizontal axis represents your real numbers, or the real portion of this complex. So we go out here to -5. The vertical axis, that's your imaginary axis. All right, this is your imaginary. So we go to 3i on the imaginary. So let's go up to here. Let's call this 3i. Down here, this would be like -3i. So we go to -5 on the real axis and up to 3i on the imaginary. And we put a point right there. And that's your point. -5 plus 3i. This is -5 plus 3i. Second part of the question is, what are the graph and the absolute value of each number? So now we need to find the absolute value of this because we want to know how far it is from this origin. We're looking for this distance right here. Because the absolute value of a complex number is its distance from the origin in the complex plane. So if we're going to find the absolute value of -5 plus 3i, all right, look, this is your A plus BI, right? So the absolute value of A plus BI is equal to the square root of A squared plus B squared. So in this case, your absolute value of negative 5 plus 3i is going to be the square root of, look what your A is. Your A is negative 5. So this is going to be the square root of negative 5 squared plus your B value is 3. So it's negative 5 squared plus 3 squared. So that gives us the square root of negative 5 squared is 25 plus 3 squared is 9, which is the square root of 25 plus 9 is what? 34? Radical 34. All right, so here is the graph. What are the graph and absolute value? Well, there's your graph, and here's your absolute value of negative 5 plus 3i. Let's graph 6i. All right, 6i. If it's 6i, it's the same as 0 plus 6i. All right? So you draw your coordinate plane. We're at 0 on the real axis, and we go to 6i on the imaginary axis. We plot a point. So there's your graph of 6i. So now we got to find the absolute value of 6i. Now, look, 6i is the same as 0 plus 6i. And we're going to use that to find the absolute value of 6i. So we're really finding the absolute value of 0 plus 6i. The absolute value of 0 plus 6i is the square root of your A value, which is 0, plus your B value, which in this case is the 6. So that's equal to the square root of 0 plus 36, which is equal to 6. So again, here's your graph. And here's your absolute value. All right, let's do one more of these. We're going to graph and find the absolute value of negative 3 minus 2i. So negative 3 minus 2i. Here's our graph. Negative 3 on the real axis. Negative 2i on the imaginary axis. So here's our graph of negative 3 minus 2i. So then the absolute value of negative 3 minus 2i is going to be equal to the square root of your a value, which is negative 3 squared, plus your b value, which is negative 2 squared. So this simplifies to the square root of 9 plus 4, which is the square root of 13. So here's your graph. Here's your absolute value. And remember that absolute value, that's the distance of that point from the origin. All right, that square root of 13 represents this distance right here. That distance is radical 13. All right, we got to add and subtract some complex numbers, and then we're going to talk about multiplying complex numbers, and then you're going to be done taking notes, and I'll give you your practice for today. So let's talk about adding and subtracting. And now we're going to find out what is each sum or difference. We got 4 minus 3i. And we're going to add to it negative 4 plus 3i. Don't know why they started with this example. But when you are adding or subtracting complex numbers, you add or subtract the real part, and then you add or subtract the imaginary part. So in this case, what you've got is a 4 plus a negative 4, right? 4 plus a negative 4. And then you've got a negative 3i plus a positive 3i. So you've got negative 3i plus 3i. So this whole thing turns out to be 0 plus 0, which is 0. Terrible first example. Let's try 5 minus 3i. Plus 4 minus 4i. So we get the 5 plus the 4, which is 9. We get a negative 3i plus a negative 4i, and that's negative 7i. It's relatively simple. Where you have to be very careful is when you're subtracting. All right, if you're subtracting and you've got 5 minus 3i again, and you're subtracting negative 2 plus 4i, what you've got here that you have to be really careful of is you got a 5 minus a negative 2. Okay? And then you've got a negative 3i minus a 4i. That's a negative 3i minus a 4i. All right, so be careful when you're subtracting because you got to use this subtraction sign twice. So what you end up with is your 5 minus -2. That's keep, change. That's a 7. And your -3i minus 4i is minus 7i. 7 minus 7i. Whose noise is that? Turn it down or turn it off. All right, now we're going to multiply complex numbers. So what is each product? Can you turn that down? Turn it down. (3i) times -5 plus 2i. This is distributive property. You got your 3i times -5. 3i times -5 is -15i. Then you've got your 3i times your positive 2i. So that's positive 6i squared. Now, I squared, all right? I squared is equal to -1. So this is where you got to do some converting. You got -15i plus 6 times -1. So what this product turns into is this 6 times -1, which is -6, minus your 15i. That is your product. (7i times 3i). (7i times 3i is equal to 21i squared. And since I squared is equal to -1, we get 21 times -1. -21. (4 plus 3i). (1 minus 2i). This is double distributive property. All right, you got your 4 times your -1 is -4. And then you've got your 4 times your -2i, which is -8i. And then a 3 times a -1, which is -3i. And a 3i times a -2i would be -6i squared. So we get -4 minus 11i minus 6 times -1. So we get -4 minus 11i. Now this -6 times this -1 becomes +6. So when we're all said and done, we got -4 plus 6, which is 2 minus 11i. So there's your product. You just have to remember this right here, that your I squared is equal to -1. All right, so when you get to the step in the problem where you've got an I squared, which is right here, Okay? Replace it with a -1. And then just continue to do your math. All right, so that's all I got for you today. So your assignment or your practice for today is on page 253. That's the handout I gave you yesterday. That's 8 through 26. And then be sure to check focus. For homework. Check focus for homework.